Hello, everyone. Thanks for coming. This presentation will take around 30 minutes, so it's not the longest one. And I just want to mention that I will not tell you how to use actually ability system. It will just be more a case study how we use it in Outriders Worldslayer. So I hope you're gonna be inspired with it somehow. All right. So a few words about me. My name is Jakub Kapuściński-Bernatek. I have around 8 years experience in game dev. First 3 years I was working with Unity, with VR games. Then I switched to Unreal Engine. And last 4 years I'm working with People Can Fly on project Outriders, Outriders Worldslayer, and currently on project called Gemini. The game plan. So in this presentation, I will talk in few words what is ability system. Then I will explain you why we decide to use that. After that, I'm going to talk what we improve in gameplay ability system just for our project. And in the end, I will mention what we wasn't able to do in GAS and how we hack it. So what is ability system? Long story short, ability system is just a plugin for Unreal Engine 4th and 5th version. And it's a tool for programmers and designers to create a skill. But you need to also know that it's a quite big plugin. So just in my opinion, if you have a small project, I'm not sure if it's a best tool for that because it's quite complex and yeah. So, history. To be honest, this is the slide that I'm most worried about, because I feel that someone could create that plugin. It's sitting somewhere here. So I hope I will not screw up this. But the story of ability system began when the Epic Games started work on two projects. One was a Paragon, and the second was a Fortnite. And as the Epic works on that project, they realized that they duplicating their effort on those two projects, and they saw a need to make a standardized tool for both of this project. And around this time, at People Can Fly, they create an experimental plugin in 4.0. And around this time, in People Can Fly, we decide to use that tool. Why? Because we believe that Epic will not abandon this tool because his main project is based on that plugin. And after sometimes this plugin was released as a completed feature in 4.6. So why we decide to use that? Our primary reason for choosing the ability system was a limited number of programmers in our project, and we saw the necessity to transfer their work to designers. Because of that, we decided to expose as much ability system into the blueprint as possibility to allow only one, and this allow us to support whole system only by one programmer. The next reason was that we had to develop over 32 skills for the player, plus hero tree, plus mode, and additionally skill for AI. Another reason was that we was creating a multiplayer game, because Outriders Slayer is a multiplayer game, co-op multiplayer game for 3 players. So we need to replicate a bunch of stuff, and ability system allow us to do this almost effortlessly. And the last reason, was numbers of dependency between skills, which we easily manage through gameplay tags. So, first of all, gameplay ability tags wasn't something that we custom create for Outriders. Gameplay tags are an integrational part of ability system, but I want to just show you in how many places we use them. Most of the gameplay tags just inform us of the status, character status, like if the player is burning, maybe if player have a slow effect on itself, that kind of thing, or maybe he's dead. But not only for that. We also use it to trigger, for example, hit reaction on player, or they inform us if a player possesses some specific weapon or armor mode. Additionally, we block some features, some functionality with those tags, like, for example, blocking skills, blocking review, weapon usage, this kind of thing. And you can see it over here. But it's actually hack. And even we use the gameplay tag to show some UI. So for example, if a player receives an armor bonus and he saw on a UI that, hey, you have a armor bonus, then it's because some gameplay tag just show up on a player character. So what we improve to that system? First of all, skill data. So skill data is a place where we start to work on any skill, mode, or hero tree. And here we could set up some basically functionality. So first we had to set up if the skill data is a skill, mode, or hero tree. Passive is actually a hero tree, mode is mode, and active is a skill. And by enum, we could also define if the skill data is only for Pyromancer, Trickster, or maybe it's a general, so it can be used by any classes. The next thing, the most important thing that we was setting here was gameplay tag or gameplay effect. So based on what we said earlier, if it's a skill, then we set up the gameplay ability. And if the skill was active, then we also active this gameplay ability. But if it was a gameplay hero tree or some kind of mode, then we trigger a gameplay effect on instigator, or maybe on a target. It's based on a design. This skill data also have a reference to curve table, and in this curve table, we could set up things like skill description or icon. But if, for example, in skill description, we have some value, so skill description was like, I don't know, you are creating an explosion with X radius and Y damage, then we had to calculate this value. So we also could set up here a class where we could calculate all of this value. Hero tree. So hero tree was very straightforward because we just simply apply some gameplay effect on player, and this gameplay effect, in most cases, just change some attribute. And later, this attribute was checked in many different places, such as gameplay abilities, gameplay effects, explosion effects, etc. But for more complex hero tree, we had to nest the gameplay ability in this gameplay effect that was applied to player. So gameplay ability. Our skills was mainly set up here, and we could trigger it many different things, like a targeting, like an animation montage, spawn projectile, etc. But while we was implementing that, we realized that, again, we are copying a ton of work. So we decided to create this interface, which maybe not look very sexy, but it was very helpful because if we, for example, decide that maybe the skill cannot be used in zone like cities, like safe zones, then we can just change one toggle and work. If we decide that, for example, this gameplay ability cannot be triggered but by some hit reaction like knockback, etc., again, we also could set up it here. There is also a bunch of options like block movement, auto-active when granted. This kind of auto-active when granted is like a possibility. So if you get this ability on a target, then it's automatically activated. You don't have to activate it with some, for example, gameplay tag. And we also here we also could set up things which we called camera state. And what is a camera state? So all of our skills change somehow camera, like with changing FOV, zoom in, zoom out, this kind of thing. And because of that, we decided to create a simple interface, so it could be modified even by a non-technical person. However, we had one skill that require a custom camera state. And this skill is a fire beam, which you can see on right corner, where a character just spawn a laser beam from the hand and apply some damage on a target. Because of that, we had to create a parent, sorry, not parent, child of the camera state, and in code we add extra condition like input restriction. All right. Another feature was def ability, and this is actually a child of our gameplay ability, but with some extra logic to handle def. But before I dive into it, I need to mention that all our def was we handled them in Gore component. And here we could set up visuals like fragmenting the mesh, spawning blood projectiles, bone fragment, all of it. And because of that, because we had this system, we had to block it somehow if we want to create something custom. And that's why we create this def ability. But because of that, we had a bunch of challenge. So we need to we had to block, for example, heat reaction. We had to block AI behavior. We had to handle the corner cases like receiving a damage. If maybe for example, if you apply the burn status on the def character, all of this thing has to be blocked in def ability. And after all of this was blocked, then the character receive information that, hey, you are dead. Then this ability has been active, and we could add some custom logic. And in these two cases, one is an impale. This is this one, where we just apply some visualization and animation, and that's all. But the second one, which is a thermal bomb, is more complex because we had to play the animation where this character is flowing. This one. And after that, when the animation is over, we had to spawn an explosion. Weapon mode. So next feature that we was developing was a weapon mode. And even in this conference, we had a conversation with my colleague about weapons in gas. So I think it's worth to mention that our weapons was working in code. And actually, we had just a data table where we could set up things like data table, like message, you know what I mean. And weapon modes was something that we add extra to this weapon. And while we was working on them, we encouraged optimization issue because when we was applying from the blueprint gameplay effect so often, for example, with minigun, when the fire rate is quite big, we had drops, and we need to put this logic to the code. So we asked programmers to help, and they create varieties of conditions under which we could trigger the gameplay effect. And here in this interface, you can see all of them. Okay. In this trigger type, where you can see this you can see where you can active the gameplay effect on shot, on kill, on critical shot, etc. And you can also determine if a gameplay effect should be applied on target, so the target that has been hit by a weapon, or on instigator, so in our cases on player. And again, if the logic was very, very complex, then this gameplay effect could have nested gameplay ability, and in this gameplay ability, we could handle all logic. But also, we had an option to just apply gameplay effect when the mode is equipped. And we also, of course, use it on weapon modes, but mostly we use them on armor mods. And on armor mods, this gameplay effect that we apply on instigator, on player, in most cases, this gameplay effect have only a gameplay tag. And our armor mods was working on two ways. One way was a general mods when armor mods could be equipped by any class, but most of the time they was specific to one classes, for example, to Pyromancer, and they changed how the skill was working. So in the main gameplay ability for a skill, we had a function where we check if the particular gameplay effect is a gameplay tag, is on player, and then we add some extra logic. And most of cases we just apply, we just send the gameplay tag to the player, and with that we apply some new gameplay ability. And thanks to that, we could have a separate gameplay ability for skill and separate ability for armor mods. And we did it because we have a bunch of them, and sometimes there was an issue where someone was working on skill, someone was working on mods, and we didn't have to wait until someone finish his work, send it to the perforce, and then we can change something. So that was one thing. And the second thing is that if we decide, for example, that during the production phase we cut some armor mods, then we could just, even if we forget to remove it from a gameplay ability in skill, then nothing will happen. For example, we will receive only warning, but we will not have any crashes because this gameplay tag that was sent to the instigator, he will just vanish. All right, Aura component. So Aura component was another optimization tool that we implement for Outriders. And let's imagine that you are creating an ability where, for example, characters around you receive armor debuff. And to that, we actually use Aura component for, because we again have some optimization issues. And I need to mention that Aura component was added to every character. And this Aura component have again an interface, which you can see here, where we could set up the gameplay effect that will be applied to the target, to the character that is affected. We could also set up the radius, and we could also set up the team. So if we want to apply this gameplay effect only to other players or to the enemies or to both of them. And with this system, actually, we did something that maybe don't looks good, but we actually calculate the distance to every character in map. So we get the list of this character in gameplay mode, and then actually on a trick or maybe something nearby trick, tick, we calculate the distance to every player, every character, and if the condition was met, and this is these conditions, then we apply the gameplay effect. And maybe it doesn't sound very optimal, but our alternative was to apply many, for example, sphere components to one target. And even if we set up this sphere component that, hey, they should only react with, for example, pound, then you need to remember that the sphere component will calculate collision to every object. Even if you said that, hey, this shouldn't calculate a collision to any object. So let's imagine that, for example, we have a 5 aura in one player, then we multiply it by 3 because we have 3 players. And for example, some mini bosses have I don't know, 2 aura. So we have a 15 sphere component on player and extra 4 on enemies. So like that doesn't sound good. And based on our tested, we decide that, hey, even a calculate to distance on a tick is better for us. All right, explosion templates. So in our game, we had plenty of explosions. So we decided to create a unified template since where we have an interface, and this interface could be easily modified. Here we could set up things like, of course, damage, radius, damage type, but also something that we called damage prevent channel. And this damage prevent channel was calculated if, for example, between explosion and character, there is some obstacle. So imagine that, for example, you are spawning the explosion that is a grenade. Then, for example, some wall, which is word static, should prevent that. But if we create something that is a trickster explosion, which is something like sci-fi slow multiverse explosion, then we don't want to prevent it by any obstacles. So we could set up it here. What we also could set up, it's a damage multiplier that was a basically attribute, and the same thing with a radius multiplier, which is also was an attribute. And this attribute, for example, could be modified in a hero tree. Gameplay queues. So again, gameplay queues is not something that we create. The gameplay queues, we just decide that we want to expand it a little bit, and we want to create this tool to be easy to use by our art team. So because of that, again, we create an interface where our artist could set up firefixes, sounds, but maybe they would like to add some offset to this firefixes. Maybe they want to attach it to the owner, or maybe they want to attach it to some specific bone. All of it they could set up here. The another thing that we decide to store every firefixes and sound here is nearly every sound and firefixes. We did it because it was just easier for artists to know where the file is. So they could filter, for example, I don't know, heatwave by gameplay queues, and they could easily find everything. They didn't need support from, for example, technical designers to show them that, hey, in this specific actor, you can set up your one firefixes, but another firefixes will be on a different, and the decal should be set up even someone else. So because of that, we use them. And another reason was because of the replication. And we as a technical designers, we didn't have to think about replication because the system did it manually, automatically in code. But we had a problem with one weapon mode, which is death ray. And in this death ray, we spawn a beam from a barrel of weapon to aim point. And we had two problems. First was a firefix, because we couldn't use gameplay queues. Why? Because we had to dynamically change the beam endpoint based on the aim point that player aim. Yeah. So because of that, it was actually a separate actor, and this actor has to be also replicated. And again, it wasn't an easy thing because we had to send it from, in server there was an issue, but in client we had to send the information where we aim to server, and then server have to replicate it to every other actors. Why? Because server don't have information where the specific player aim. And also here you can see video with first prototype of this skill, of this mode. And I'm showing you that because actually it's my own child, it's my own creation, so I just want to show you. All right, AI in ability system. I just want to say that I want to mention that, but I wasn't working on that. So this is actually what I find out based on a talk with my colleagues. However, I know the reason why they decided to do that. And the reason was the same that why we did it in player experience team. Because, again, they have a lack of number of programmers, and they need to transfer this work to designers. The problem that they had was multiple checks. So before in behavior tree they active any gameplay ability, they had to check things like cooldowns, cost, etc. And then again, before gameplay ability was active, in code, this check, for example, for cooldown was checked back again, and it wasn't great. But we had to work with that, and in the end, it was work quite good. All right. So what we wasn't able to do in ability system. We had a problem with spawned actors. And the turret is the easiest example to explain you, because we know that in many games, we had a skill that just spawned turret, and basically we know how it works. But gameplay ability system doesn't support separate actors, and because of that, we had to separate part of the logic, part of the skill logic to the actor, to the turret actor, and the second part was still in gameplay ability for players. So things like, of course, animation, cooldown, targeting was still in gameplay ability. But the things like detecting enemies, applying damage, that thing was handled in separate actor, in turret actor. And also in this left corner, you can see turret, which spawns some projectiles and apply damage on enemies. But actually, it's a fake, because, OK, we have a separate actor, which is a turret, and it spawns some projectiles, but those projectiles are not the projectiles. They are FFX. And so you can ask how we detect that we hit something. We create something which we called overlap component. And this overlap component basically worked like a collision, but we could set up things like a shape. So if it's a box, it's a sphere. But we also could change size of, or we could just move it through the map. Another thing that this support was moving with a floor. So if we have some kind of ramp, then it could go straight up or straight down. And we not use it so in this turret we just move the box collision through the wall, through the floor, where we detect that we hit something, and then we apply the damage on it. But we don't only use it on turret, we also use it on skills like a heat wave, and you can see it here in our debug map. And the last thing that I think is worth to mention is damage type. Again, damage type is not something that we create for Outriders, but we put a bunch of logic for skills into them. So for example, if you want to trigger some hit reaction by tag, gameplay tag, this gameplay tag could be set up here, like you can see in here in event knockback. Another thing was gore. So as I mentioned previously, we had a gore component, and all of the things like what kind of blood we want to spawn, do we want to rip, I don't know, hands or leg or maybe head. These things also could be was set up in damage type. And the last thing was that we could apply gameplay effect on target. So let's imagine that, for example, we create a weapon where our rifle, and we decide that, OK, now this rifle will apply damage, will apply fire status on the target that it hit. So normally we will have to, I don't know, bind to some function like, OK, on hit do something, and etc. Check if this is the thing that you hit was a character, and etc. etc. But thanks to that, we could just switch the damage type on Rifleman, and on effect to apply, we apply fire status on thing that we hit, so basically on a target. That all was handled in code, so again, it was thanks to that, it was also optimal. And that's all. So if you have any question, I will be happy to answer.